Hooke's law 5F. So a spring has an unstretched length of 0.40 meters. The spring is stretched to a length of 0.60 meters. So your change in distance, right? Your change in length is 0.20 meters, right? And you have a 10 Newton weight, so your force due to gravity on the spring is 10 newtons. And so what is your spring constant? Well, which one of the two formulas are we going to use? Well, we have Fg, we have X, and we have K. So we're most likely going to use this formula, right? Where Fg is the force on the spring. So K, 0.2 divided by 0.2. And so we're going to get a spring constant of 50 Newton meters. So the answer is D. Number 2. Spring constant, Newton over meters. Downward force, so your force on the spring is 12 newtons. As applied to the free end of the spring, spring stretches a distance of what? So again, the one or two formulas we're going to use. We don't have potential energy, so we're going to use force on the spring. So 12, 68 x divided by 68, we should get somewhere around 0.18 meters. And so that's the answer. The answer is A. 3. Placed on a spring with a spring constant of 60 Newton meters. The spring is compressed 0.5 meters. How much energy is stored? So the formula we're going to use is PE because we don't have a force. So 1/2 kx squared, 1/2 60.5 squared. 0.5 squared is 0.25. 0.25 times 30 here. You're going to get 7.5 joules. And so that's the answer. The answer is D. Number 4. A spring gains potential energy is 2.34 joules. Compressed 0.25 meters from the equilibrium position. So what is our spring constant? And so the only formula we can use, because we don't have force, 1/2 kx squared. So 1/2 k x squared is 0.25 squared. P is 2.34. 2.34. 0.25 squared times 0.25, I get 0.0625. So 1/2 k 0.0625. 2.34. 1/2 times this is 0.03125 k divided by this. I'm just gonna look at the choices, see which answer best fits this before I use Google Calculator. Um, it looks like D is the correct answer. So that's actually, let me just use a calculator. Yeah, it's D. It's D. So we get an answer of 7.488, right? And so that's our answer. 74.9. So that's D. Five, a spring constant 4 Newton meters compressed by a force, so the force on the spring is 1.2 newtons. What is the total elastic potential energy stored in the spring? So what is my potential energy? Well, let's first figure out what my force on the spring, how much I stretch it, right? How much do I stretch this spring? So my force on the spring is 1.2. K is 4, so let's figure out what X is. Divide by 4, I get 0.3 meters. So it gets stretched a distance of 0.3 meters. Well, now we can solve for potential energy. 1/2 kx squared, right? 1/2 k is 4, x squared is 0.3 squared, 0.3 squared. It gives me something. I think it gives me like 1.1. Not sure, not too sure. 0.09. So 1/2 times 4 is 2. 0.3 squared is 0.09. So this gives me 0.18 joules. So the answer is A. Six. So in this problem, right? So there's a total transfer of energy from the cart to the spring. Let's say that it's a frictionless horizontal surface, so your change in internal energy is 0. There's no loss due to heat energy. So there's a perfect transfer of 16 joules of kinetic energy. There's a perfect transfer from the cart into the spring. So now once the cart hits the spring, all of that energy is going to be transferred. So your potential energy of the spring is 16 joules. Then once you come to this conclusion, well, x you compress it by 1 meter, and they want to know what your spring constant is. Well, then you just do this. Is kx 16, k 1, and then so k is 16 Newton meters, and that's B. That's 5F Hooke's law.